Did you know that the foundation of modern AI started with a single, simple model in the 1950s? Meet the Perceptron, a deterministic, supervised learning algorithm introduced by Frank Rosenblatt. It's a linear classifier designed for binary classification tasks, using a mathematical approach to decide whether data points belong to one category or another. This straightforward yet powerful idea paved the way for the neural networks that power today's technologies. Let's dive in. A perceptron takes multiple inputs, like features of data, such as email length, or contains links. Each input is multiplied by a weight, which is just a number showing how important that input is for the decision. For example, in spam detection, the weight for contains suspicious words might be higher than email length. Next, it adds up all the weighted inputs, and here's the interesting part, we add a bias. The bias is like a push or offset, it adjusts the threshold, helping the perceptron make better decisions, even if the inputs aren't perfect. Think of bias like adding training wheels to help balance a bike, it gives the perceptron flexibility. Now, let's talk about the activation function. This is a mathematical function that processes the weighted sum of inputs and decides the perceptron's output. In the perceptron, we use a step function, which works like this. If the total sum of inputs and weights crosses a certain threshold, it outputs 1, if not, it outputs 0. Think of it as a light switch either on or off, depending on the total score. But what exactly is an activation function? It's like a gatekeeper that decides whether a neuron should activate or stay quiet. Without it, the perceptron would have no way of distinguishing between important and less important patterns. In modern neural networks, we use more advanced activation functions like sigmoid or ReLU, rectified linear unit. These allow us to handle complex, nonlinear problems by adding flexibility. For example, sigmoid maps values smoothly between 0 and 1, while ReLU outputs 0 for negative inputs and keeps positive values unchanged. But perceptrons have a limitation, they can only solve linearly separable problems. For example, if you're classifying apples and oranges, it works if a straight line can separate them. But it fails with more complex problems, like XOR, where no straight line works. The solution? Combine perceptrons into multi-layer neural networks. These layers use advanced activation functions, like sigmoid or ReLU, and are trained using backpropagation, a method to update weights and solve nonlinear problems like recognizing faces or detecting fraud. The perceptron's simple idea evolved into today's AI. It's the backbone of technologies like spam filters, chatbots, recommendation systems, and even self-driving cars. Studio microphone, and that's the perceptron. Want to learn how neural networks evolved into today's AI giants? Follow for more tech insights.